Hello there. In this video, we will be learning about what are physical quantities, what are different types of physical quantities, and the basics of dimensional formula. Now, imagine a situation where you are not feeling well and you go to a doctor and you tell to the doctor that, hey doctor, I'm not feeling well. Now, feeling is something that cannot be quantified. So the doctor cannot give you medicines just on the basis of this feeling. So generally what would the doctor do? The doctor will measure your body temperature. Now, what is this temperature? Temperature is something that could be measured. For an example, your body temperature comes out to be 100 degree Fahrenheit. Now, with the help of this, the doctor can get to know that, okay, it seems like you have high fever. And with the help of this information, the doctor would be able to give you the medicines for fever. Now, what is this thing called temperature? Now, temperature is something that is measurable, right? That's what 100 degree Fahrenheit represents. But feeling is something that cannot be measured. So in physics, anything that can be measured is what is called a physical quantity. So the precise definition of a physical quantity is the physical quantities are the properties or characteristics of an object or the phenomenon that can be measured. For an example, you have a table and you want to take the measurements of this table. Now, what would you need? Let's say you take a scale and measure this particular side. We call this as length. Now, length can be characterized as a physical quantity because it is something that can be measured. Similarly, for this table, you can measure its mass. So, mass is yet another physical quantity. So, you can measure the volume of this table. That's yet another physical quantity. So all these things, volume, mass, length, these are what are called the physical quantities. Now, we can characterize these physical quantities into three types. One is what is called the fundamental or the base quantities. The second type is what is called the derived physical quantities. And the third is what is called the supplementary physical quantities. So what's the basic difference between all these three kinds of physical quantities? Let's understand. So the first are the fundamental quantities. Now, the fundamental physical quantities are the one that are independent from each other, and in order to represent one, you don't need the help of any another physical quantity. So the definition of fundamental physical quantities is these are the basic quantities that are independent and cannot be defined in the terms of other quantities. For an example, length. So length and mass are the fundamental physical quantities. In a way, you can say that you can't represent length in the terms of mass or mass in the terms of length. So we can say that length and mass are the fundamental physical quantities. So based on our SI system, that is the International System of Units, there are these 7 fundamental or the base physical quantities: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. So these are the fundamental physical quantities. What it means that in order to define length, you are not dependent on time. And similarly, you can say that in order to define temperature, you are, let's say, not dependent on length. So these are independent from each other, and that's why these are called the fundamental physical quantities. And these are the respective units of these fundamental quantities, and these are the SI units of these fundamental physical quantities. Now, we can also define dimensions to these physical quantities. That would be like length can be simply represented as capital L with square brackets. Mass can be simply represented as capital M with square brackets. Similarly, time could be represented as T with the square brackets, and similarly for the electric current it is I with the square brackets, temperature it is theta, amount of substance N, and the luminous intensity J. Now, you can yourself see that this L and T, like while we are writing the dimension of time, we don't need length or mass. Similarly, when I am writing the dimension of mass, that is not getting dependent on N or J or L, right? So these are independent to each other, and that's why these are called the fundamental physical quantities. Now, let's understand what are derived physical quantities. So derived physical quantities would be something like speed. Now, in order to define speed, we need to know what is the distance and what is the time. So speed is defined as distance traveled divided by time. Now, distance is nothing but length, right? Like how do you measure distance? In meters. So it can be just written as L, and the dimension of time we just studied that it is T. Now, see, in order to define speed, we are dependent on both these physical quantities, right? One is L and one is T. So, in a way, we can say that speed is a derived physical quantity, a physical quantity that is dependent on two or more physical quantities. So, this is what is called the derived physical quantity, the physical quantities that are derived from the fundamental quantities through mathematical relationships or formulas. Answer this question. Let's say I'm interested to find whether area is a fundamental physical quantity or a derived physical quantity. Now, how do we define area? For an example, I'm interested to find the area of a square. So it would be side multiply by side. Now, one of the sides could be measured as length and the another side could also be measured as length. Now, this area is dependent on length. That's it. That's the physical quantity it is dependent on. So, would it be characterized as a fundamental quantity? Because in a way you can say that it only depends upon length. It doesn't depend on any other physical quantity. But this is also characterized as a derived physical quantity. The reason being that any physical quantity that can either be expressed just like L or T or M, that would be considered as a fundamental physical quantity. But even if there is a physical quantity that can be expressed as L square, that is 2 times of L, that is also considered as a derived quantity. So similarly, volume that is written as meter cube, that is L cube, that also comes under the derived physical quantities. So there is no limit of the derived physical quantities, because everything that you study in physics, from let's say velocity to acceleration to frequency to density and so on and so forth. So all these physical quantities are called derived physical quantities. So anything that you see is not in the list of this 7 would be considered as a derived physical quantity. Then what are supplementary physical quantities? Now, supplementary physical quantities would be the ones that can neither be classified as a fundamental physical quantities nor be characterized as a derived physical quantity. So the definition would be: supplementary quantities are the physical quantities that in the International System of Units, that is the SI system, are not classified as either fundamental or derived physical quantities but are essential for measurement and describing the physical phenomenon. There are these two types of supplementary physical quantities. One is called plane angle and the another is called solid angle. Plane angle is simply, let's say you have a pizza, there is a slice of pizza. So this angle is what is called a plane angle. And the solid angle would be, let's say you have a birthday cap. So this angle would be called as a solid angle. So both these angles, that is the plane angle and the solid angle, are neither fundamental physical quantities nor derived. So these are another set of physical quantities that we call as supplementary physical quantities. Lastly, let's understand what is a dimensional formula of any physical quantity. So for the fundamental physical quantity, for an example length, it can be just written as L in the square bracket. For a mass, it can be just represented as M, capital M with a square bracket. And for the time, we can just write it like T with a square bracket. For an example, if you are interested to find the dimensional formula for density. Now, density is mass per unit volume. Now, mass is represented in kilograms and the volume is in meter cube. Now, what is this kilogram? So, kilogram is nothing but the SI unit of mass. So, I can just write its dimension as M. And what is meter cube? It is nothing but length cube. So, I can just write it as L cube. So, I can say the density can be represented as M raised to the power 1 L raised to the power -3, and I can also represent it as T raised to the power 0. Now this entire equation is what is called a dimensional equation, and these powers are what are called the dimensions. So in a way we can say that the dimensions of density in mass is 1, in length it is -3, and in time it is 0. Similarly, let's say if we are interested to find the dimension of acceleration. So acceleration is change in velocity divided by change in time. Now velocity is measured in meters per second and time in second. So I can write this as meter per second square. Now, meter is nothing but length, so I can just write it as L with a square bracket, and second square can be just written as T square. So the dimensional formula for acceleration, m raised to the power 0, L raised to the power 1, and T raised to the power negative 2. So this is the dimensional formula for acceleration, and likewise you can find the dimensional formula for all the derived physical quantities. So just as a recap, physical quantities are all the quantities that could be measured, and there are these three types of physical quantities. The fundamental or the base quantities, we have 7 such quantities that are independent of each other. Derived quantities are all the other physical quantities that are derived with the help of these fundamental physical quantities. And the supplementary physical quantities are the exception, that is angles that are neither characterized as a fundamental physical quantity or the derived physical quantity. I hope you understand about the physical quantities, the types of physical quantities, and the basics of dimensional formula. See you in the next video. Bye-bye.